Today I want to talk about how the body shapes communication. Not just words but sensation, movement, timing, and support. This is about understanding why communication feels easier some days and harder on others. Before we go on, you will see a short thought question under each slide title. These are something to reflect on at your own pace. You'll also see some neuroscience terms on some of the slides. Those words don't belong only to therapists, clinicians, or researchers. They belong to you too. They're names for real things your bodies experience. Communication is physical. It requires energy, coordination, and regulation across the nervous system. When those systems are taxed, communication becomes harder. This is why communication can disappear, even when understanding is still there. A useful way to understand communication is as a loop. The body senses, the brain plans, the body moves, and then the system adjusts. The first step is sensing. Your body is always taking in information, often more than you asked for. When too much sensory input comes in at once, the rest of the loop has less capacity to work. The thought question here is, what sensory input costs the most energy? Next, let's look at how does your body know what it needs. There is a label for this: interoception. Interoception is the sense of what's happening inside your body: hunger, pain, breathing, bathroom needs, heart rate, tension. For many autistics, including non-speaking autistics, interoceptive signals may be weak, delayed, or overwhelming. That makes it hard to notice needs before they become crises. What happens when internal signals are unclear? If your body doesn't clearly signal hunger, pain, or stress, the sensory motor loop gets overloaded. Communication often drops, not because of language, but because the body is in trouble. Most emotions start in the body as physical sensations: a racing heart, tight chest, warmth, nausea. Alexithymia means difficulty identifying or interpreting those sensations as emotions. When internal signals are hard to interpret, regulation often happens late. The body may already be overwhelmed before the person knows what's wrong. For example, think about heart rate. It goes up when you're exercising, and it also goes up when you're getting anxious. Those two states feel very different, but in the body, the signal can look the same. If your system can't easily tell the difference, you might start feeling anxious even during healthy exercise. This is often mistaken for emotional volatility, but it's a timing issue. Once information comes in, the next step is planning. This is where the brain decides what to do, when to do it, and how to do it. A lot of work happens here, often before anything is visible to other people. Planning doesn't stop with deciding what you want to do. The body still has to figure out how to turn that intention into action. This step is called motor planning, or praxis. It's the bridge between knowing and doing. Only after all that planning does movement happen. This is the part other people usually see: pointing, typing, spelling, speaking. But by the time movement shows up, a lot of work has already happened. This step often costs the most energy, and different movements, cost different amounts. After movement, the system doesn't just stop. The body checks what happened. Did it match the plan? If not, it has to adjust, which means the loop starts again. This loop doesn't run once, it runs constantly. When the loop runs smoothly, communication may be somewhat less effortful. When one part is overloaded, the whole system has to work harder. Sensory-motor integration describes how hard this loop is to run. It's about effort, not ability or motivation. When does effort get mistaken for inability? When effort gets too high, the system protects itself. That can look like fatigue, shutdown, inability, or needing more support. When one part is overloaded, the whole system has to work harder. Reducing demands gives the sensory-motor loop more capacity. It can help communication improve not because someone tries harder, but because the system can finally do the work it was already capable of. As the loop keeps running, some tasks ask more of it than others. This is where motor planning load comes in. Some actions require the body to sequence movements very quickly, very precisely, or under time pressure. Fast, timed actions cost more energy, especially when they're public or evaluated. For example, timed exams, being put on the spot to answer quickly, or having to perform in front of others. For alternative communication users, that might also look like pressure to type quickly, respond immediately, or communicate in group settings at the same rapid rate as oral speech. When tasks place a high load on the system, the question becomes, what actually helps? Supports don't change the person. They change the operating conditions of the nervous system, how much effort is required just to stay regulated and organized. There isn't one kind of support that helps everyone in the same way. Different supports work on different parts of the loop. Sensory, motor, environmental, and relational supports each reduce load in different places. We can make use of sensory supports to reduce noise in the system. They don't make someone comfortable, they make communication possible by freeing up bandwidth. The thought question is, which inputs drain energy, and which restore it for any particular autistic? Once sensory load is reduced, the next question is how the body organizes movement. Motor supports reduce the effort required to plan and execute movement. The thought question is, what helps your body organize movement? For alternative communication users, posture and stability can make the difference between access and shutdown. Environmental supports reduce surprise. The thought question here is, how does the environment help, or fight, your system? When routines are predictable and transitions are clear, the brain has fewer things to constantly repredict. That lowers prediction error and frees up capacity for potential communication. Prediction error isn't just about the outside world. It can also happen inside the body, when sensations don't match expectations. Both kinds of mismatch cost energy. Reducing them helps the sensory-motor loop stay online. Before the system tips into overload, certain kinds of movement can help it stay present. Repetition and rhythm give the nervous system something predictable to organize around. These patterns can support regulation before the system becomes overwhelmed. Active regulation is the nervous system working to maintain stability in the face of demand. Regulation isn't passive. It takes effort. After the system has worked to stay regulated, it also needs ways to return to baseline. These are called regulation supports. Movement, rhythm, and repetition are common ways the body does this. For many autistic people, stimming, or repetitive movements, sounds, rhythms, is one way the body tries to regulate itself. Stimming can help manage sensory input, organize movement, or keep attention steady. Not all stimming helps in every context. Some forms support regulation. Some don't help much. And some can become compulsive or interfere with functioning, especially when the system is overwhelmed. The goal isn't to stop stimming. It's to understand which forms actually help this body regulate, and which increase distress. Co-regulation means another person helping the autistic nervous system stay regulated, through calm presence, predictable responses, shared rhythm, or reducing pressure. Co-regulation means another person helping the autistic nervous system stay regulated, through calm presence, predictable responses, shared rhythm, or reducing pressure. The goal isn't to eliminate movement or support. It's to understand what helps this body return to baseline, and what makes regulation harder. Up to this point, we've been talking about bodies, effort, and access. When systems aren't designed for real bodies, they need simple ways to explain the mismatch. That's where false binaries come from. False binaries oversimplify bodies. They appear when systems don't fit the people using them. One of the most common places this false binaries shows up is around speech. Speech ability doesn't define communication or intelligence. Another false binary is that people are often labeled calm or dysregulated. But regulation changes moment to moment, depending on sensory load, interoception, and support. This isn't a character trait, it's physiology. Another place this same false binary logic shows up is in how we talk about independence. People often talk about independence as if it means doing everything alone. But no one actually lives that way. In daily living, we all depend on other people, on shared systems, tools, and support. For many disabled people especially, independence means being able to act, decide, and participate, with support. Support doesn't erase effort. It redistributes effort, away from fighting the environment, and toward doing the thing you actually want to do. So the real question isn't independent, or needs support. It's whether support increases access, agency, and choice. Once we move past binaries, we can ask better questions. Instead of sorting people into categories, we can ask about effort, conditions, and access. Those questions tell us much more about what's actually happening. When we ask those questions, something becomes clearer. Different ways of communicating place different demands on the same sensory motor loop. Speech, alternative communication methods, and other forms of expression all draw on the same system, just in different ways. Let's look at what that means in practice. When we look at communication through the lens of effort and access, alternative communication technology and methodologies looks different. It isn't a backup or a last resort. It's a valid, complete way to communicate that works with the body, rather than against it. If we step back and look at the whole picture, this model helps explain a lot of everyday experiences. Fatigue, variability from day to day, and changing support needs stop looking random or personal. They make sense as changes in effort, load, and access, not as failures of motivation or ability. So if there's one thing to take away, it's this. Different bodies need different kinds of access. When we start there, when access comes first, communication becomes more possible in the ways that actually work for each person.